Number 31. A particle moves on the coordinate line with position s of t equals t cubed minus 6t squared plus 9t plus 4. And we're trying to determine the time interval when the particle moves to the left. It moves to the left when the velocity is negative, or less than 0. So the velocity is the derivative of the position function. Using the power rule, you have 3t squared minus 12t plus 9. To determine where that's negative, I find it easier to determine where it's 0, and then 0 divides the positives from the negatives. Examine the number line in that respect. What I do is determine where the velocity is 0. So I set the velocity equal to 0 and solve for t. Oh, we can factor out a 3, and that makes the factoring easier. So then we can break that down into t minus 1 and t minus 3. So the velocity is 0 when t minus 1 is 0, or at t equals 1, and when t minus 3 is 0, or at t equals 3. So our time, t greater than or equal to 0, is divided up into 3 intervals. We have something happening from 0 to 1, something happening from 1 to 3, and something else from 3 to infinity. And I'm trying to determine what the sign is of the derivative. The derivative, you know, is velocity. If I pick a number in each interval and determine what the velocity is, then I know which direction it's moving. So a number between 0 and 1 is 1/2. Well, 3 is a positive number. It's a positive number no matter what. 1/2 minus 1 is a negative number. 1/2 minus 3 is a negative number. If you multiply a positive and two negatives, what do you get? A positive. So that's telling me that in the interval 0 to 1, the particle is moving to the right. It's moving in a positive direction, which is to the right. In the interval 1 to 3, I pick a number, 2. 3 is positive. 2 minus 1 is positive. 2 minus 3 is negative. When you multiply those together, you get a negative. So it's moving to the left in that interval. And then you check the last interval, same way, pick a number like 6, and you will find that all factors are positive, therefore it's moving to the right. So to answer the question, it moves to the left when t is in the interval 1 to 3, since the velocity is negative. So you have this conical icicle, and the height is 12 centimeters. The height is increasing at a rate of 1/2 centimeter per hour. At the time when the height is 12, it says the radius is 1, and the radius is decreasing at a rate of 5/100 centimeters per hour. So you have to represent decreasing as a negative. So this icicle is getting more narrow. Then you are to find whether or not the volume is increasing or decreasing, and by what rate. Also, the volume is 1/3 pi r squared h. I'm trying to find dV dt. Pi r squared h all over 3. That's the same thing. So looking at the equation, we're trying to find dV dt, so we need V to be in there. R, we have a dr dt, so R can stay. H, we have a dH dt, so H can stay. We keep all of the variables in here because we know all of the related rates. That means we're taking the derivative using the product rule. So you have the derivative of V with respect to t. And on the right-hand side, I would lump the 1/3 pi r squared as one function and the h as the separate one. So I say 1/3 pi r squared times the derivative of h, which is 1 dH dt, plus h times the derivative of 1/3 pi r squared. 2/3 pi r dr dt. Does that make sense? Now we just put in all of our numbers. We're looking for dV dt. We have that the radius is 1. dH dt is 0.5. I'm going to change it to a fraction because I can't multiply decimals in my head. H is 12. Then you have 2/3 pi times 1, and dr dt, -5/100, -5/100, and then you just do the arithmetic. So for the first part, I have pi over 6. For the second part, 12 times 2 times pi times -5 is -60 pi, and 3 times 100 is 300. So I can reduce that and then get a common denominator and add. Are you with me? Okay. So I would reduce that to -6/30, just dividing each one by 10. And then a common denominator that would work well would be 30. So I want to change this 6 to a 30. 6 goes into 35 times, so that would be 5 pi. And this is negative 6 pi over 30. So the volume, or dV dt, is negative 1 pi over 30. Okay, do I have a mistake? Did I multiply right? 10? I didn't. Y'all just let me do it. 10 times 12, that should be 120, not 60. Darn it. I have to find my own mistakes. So negative 120, that means that would be 12/30ths. So it's negative 7 pi over 30. And the question was, is the volume increasing or decreasing? And by what rate? It's decreasing because we got a negative answer. So we would say it's decreasing at a rate of 7 pi over 30 cubic centimeters per hour. Don't say it's decreasing by negative 7 pi over 30. You see, double negative. Decreasing implies that it's negative. This is what, number 34. In number 34, the square has a side of 6, so the area of that square is 36. What is the length of the diagonal? So yeah, but the problem is we don't know the rate at which the side is changing, do we? We're not given that, and we don't care about it. So let's call the diagonal x. So what I know is dx dt is 3. I need to come up with an equation for the area of this square using only x. That x. And that's what I was trying to get you to understand. If these are 6, what is the length of that diagonal? You said you could use the Pythagorean theorem. The square root of 72, which is 6 square root of 2. In a square, the diagonal is always the side times the square root of 2. Okay, so I told you that the area of a square is half the product of its diagonals. The diagonals are equal. If I multiply the two diagonals, square root of 72 times the square root of 72, and take half of it, what do I get? So do you understand why the formula works? So that is the formula you need to use to find the derivative, because we know nothing about how these sides are changing. I don't think. I don't have my paper here. Okay, we can't find it. So we have to make our equation involving what we know and what we're trying to find. We can't use a variable in there that we don't know anything about. So the derivative of a is dA dt. The derivative of 1/2 x squared is x dx dt. So do we know x? We just found it, didn't we? 6 squared root of 2. The x dt is 3. So the area is changing at a rate of 18 times the square root of 2 square meters per second. Okay. What happened to my other pages? Oh, how did I do that? Okay, let me go back to here. Excuse me. Sample FRQ. Suppose you have the function f of x is the square root of the quantity 1 minus cosine of x. Part A. What is the domain? Part B. What is or find f prime of x? Part C. What is the domain of f prime of x? And part D, write an equation for the line tangent to the graph of f at x equals pi over 2. So let me give you a few minutes to attempt that and then we'll talk about it. In part A, what is the domain of f? Well, when I'm finding the domain of a function, I check two things. I check to see if it has a radical, because if it has a radical, I need to make sure that the part underneath the radical is positive. The other thing I check is to see if it has a denominator, because I don't want the denominator to be 0. So for this particular problem, we don't have the denominator thing, but we do have the radical. So we need to make sure that 1 minus cosine of x is greater than or equal to 0. So I solve that inequality. To solve it, I would subtract 1 and divide by negative 1. When you divide by a negative, it flips the inequality symbol. So now I want to know what numbers I can put in for x to make sure that the cosine of it will be less than or equal to 1. When you take the cosine of an angle, don't your answers always fall between 1 and negative 1? So is there any number you can put in there for x that will make the cosine of it greater than 1? So that means x is all real numbers, negative infinity to positive infinity. Well, in part B, we want the derivative. And you said you got that? Yes, do that. Great. Okay. Power rule. Mhm. Not, not one. Just sine of x. Okay. And that's the derivative, but you're going to have to work with it in part C. Very good. So now in part C, we want the domain of the derivative. Well, this one not only has a radical that we need to make sure the number is positive under there, but since it is in the denominator, we don't want it to be 0. So we need to say, I want 1 minus cosine of x to be greater than 0. I don't want it to be equal to this time. Do you understand? So solve the inequality. The cosine of x is less than 1. Now I want to know what numbers I can put in there to make sure the cosine of it will be less than 1. Everything except 0 and 2 pi, or actually multiples of 2 pi, because 0 or 2 pi will make the answer 1, and I don't want it to be 1. So I would say x is all real numbers except n times 2 pi. That takes care of 0 times 2 pi, 1 times 2 pi. Pause for a question. Okay, so what do we need to know to find the equation of a tangent line? The slope and a point. How do we go about finding the slope? And we have done that, right? We need to find f prime of pi over 2. So we have the sine of pi over 2 over 2 times the square root of the quantity 1 minus cosine of pi over 2. What will that be equal to? 1/2. So I have the slope. Do I have the point? I have x. And if I have x, how do I find y? The original equation. I need to find f of pi over 2. The original equation was the square root of the quantity 1 minus cosine of x, and x is now pi over 2. So what is y? Okay, so now I have my point, and I have the slope. Put it in point slope. Okay, so we're going to extend this problem one more time and determine if there is a horizontal tangent line and a vertical tangent line. So to find the horizontal tangent line, what do? It's when the slope is 0. So we take the derivative and set the numerator equal to 0. When is the sine of x 0? 2 pi or 0. So my original equation was f of x equals the square root of the quantity. Oh, I don't need that. Never mind. I don't, yes I do. Yes I do. Because a horizontal tangent line is a form what? Horizontal line. How do you write the equation of a horizontal line? Y equals. Are any of these y equals? We need to know what y equals when x is one of these numbers. So my original equation will tell me what y equals when I plug in one of these numbers. So the cosine of 0 is 1, so that would give me y equals 0. What about if I put in pi? 1 minus the cosine of pi is 1 minus -1. So wouldn't that be y equals the square root of 2? So this function, whatever it looks like, has a horizontal tangent line at y equals 0 and another one at y equals the square root of 2. It must bump up and down between those two. Okay? So for the vertical tangent line, how do we find those, you said? Set the denominator equal to 0. So I'm going to, let me label this, vertical tangent line. And the denominator was, okay, 2 square root of the quantity, 1 minus cosine of x. I want to see where that will be equal to 0. So how do we solve that? Excellent. Divide by 2 and square both sides. And then what? And so x equals what? 0 or 2 pi. Not pi this time. So we have vertical tangent lines every 2 pi radians. The same as the what? Okay, the question was to do another example where we have to find the second derivative using implicit differentiation. Suppose we have the function x squared plus sine of y equals y plus 2. So the first derivative will be 2x plus cosine y dy dx equals dy dx. At this point, I want to get all of my dy dx's on one side of the equation so I can isolate it. And I'm going to do that by subtracting the cosine term from both sides. Once I do that, I will factor out dy dx, What does that leave me with? 1 minus cosine y. Therefore, dy dx is 2x divided by the quantity 1 minus cosine y. Now I want the second derivative, the quotient rule. And of course the derivative of the right-hand side is just d squared y dx squared. And I'm going to put it on the left. Is that okay? And then I'll do the quotient rule here. So low d high. What is d high? Great. Minus high d low. Sine y dy dx. And this is all divided by 1 minus cosine of y squared. Now I'll make it look better. We cannot cancel out the 1 minus cosine y. Who said that? The one in the orange shirt. We cannot cancel out 1 minus cosine of y. We could distribute the 2. We can distribute the minus 2x. And we can replace dy dx with over 1 minus cosine y. And then we need to get a common denominator in the numerator. What would the common denominator be? Okay, this is going to be awful. This is what happens when I make out a problem. Look, 1 minus cosine y under that, and 1 minus cosine y under this part. This part is easy. That's just going to be 4x squared sine y. But what do we have to do for this? FOIL. I'm going to write this down and do it in the next step. You won't have one that's ridiculous. But the thing is, if you can do one that's ridiculous, then you can do the easier ones. Are you following what I'm doing? Okay. So now I need to FOIL this out. Well, it'll be 2 and 2 more, so 4 cosine y plus 2 cosine squared of y minus the other numerator. And how about the denominator? 1 minus cosine of y, how about cubed? All of this is over 1 minus cosine y. Then you're going to invert and multiply, and it ends up being cubed. I modeled this problem after a recent FRQ that you have done. I would highly recommend you looking back at that FRQ. One through 5. Probably closer to the end. You do have them in chronological order in your notebook, I assume. I would start from the back and work forward looking at them. It will be easy to spot. This is number 72 on page 198. The radius of a right circular cylinder is given by the square root of the quantity t plus 2, and its height is 1/2 the square root of t, where t is time in seconds and the dimensions are in inches. Find the rate of change of the volume with respect to time. Well, a right circular cylinder, that is a drink can. The volume is pi r squared times h. We are given r in terms of t. We are given h in terms of t. So we rewrite the volume equation in terms of t by making these substitutions. So when I square the square root, that will give me t plus 2, and then I have the 1/2 square root of t. So that's about as good as I can get. I can't distribute the t plus 2 over square root of t. So to find the derivative with respect to t, I'll use the product rule. So I'll call this the first function and this part the second function. So pi times the quantity t plus 2 times the derivative of 1/2 square root of t, which I think of as 1/2 t to the 1/2, is 1/4 t to the negative 1/2. Then I have 1/2 square root of t times the derivative of pi times t plus 2, which I can think of as pi t plus 2 pi. The derivative of pi t plus 2 pi is pi. T is the variable. This is like 2t plus a number, so it's just the coefficient of the t.
So when it's just pi by itself and there's no like x or y with it, then it's just 0.
Right.
Okay.
Okay, so then we can simplify this. This t to the negative 1/2 goes in the denominator along with the 4. And in the numerator I have pi times t plus 2. And this other one is pi over 2 square root of t. And now I need to get a common denominator. 4 square root of t. That's okay. Which means this one doesn't change. And I'm probably going to need to distribute there in order to combine it. So I'll go ahead and distribute pi to get pi t plus 2 pi. And over here, very good. So that's going to be 2 pi t. So then we can combine the pi t and the 2 pi t to get 3 pi t plus 2 pi over 4 square root of t. we weren't given any numbers to get a specific volume. They didn't give us any numbers to use for T, so that's it. That would be cubic inches per second.